Hello, good morning. I'm happy to present technology-enabled sustainable agriculture, in particular the agroecology case. So I'm Philippe COUSIN from the SENSEEN SME. But this article has been done with Olivier Husson from the International Research Center and also two friends from Senegal, Ousmane Thiaré from University of Gaston Berger, who is the dean of the university, and Gora Indian, who is running an agroecology farm in Kadira. What are the problems? The problem is a lot of issue in traditional conventional agricultures. We are losing organic matter, so the soil are eroded. From 1920 to now, we lost. We have 5% of organic matter, and now we have 2%. So we lost of organic matter. We lost of fertility. We lost of biodiversity. We have increase of gas emission, and we have bad water quality, and we have ecosystem poverty. So we are facing a lot of issue in conventional agricultures. One answer to address the issue is to set up a global answer, in particular what we call agroecology. So agroecology, first of all, there are several concepts. The concept is no tillage. So we are not putting oxygen in the soil because we are not doing any tillage. We have a permanent soil cover, and also we have a species diversification. So this approach is also a lot discussed and addressed in Africa. And for instance, you have plenty of organizations, and we can, for instance, mention Alliance for Food Sovereignty Africa. They have a complete success story in Africa. And we are working, for instance, with the agroecology farm of Kadira. And we see that when it was kind of desertified land in 2010, which is today very fertile and very good background with agroecology approach in 2020. So how to measure the agroecology? Because we need to help to move on to agroecology. First approach in research, and something we have developed, we have documented in the paper, is we have using IoT and big data. In UGB, they also deploy a lot of sensors to measure, in particular, moisture. And they are also cooperating with an EU-Africa project called WASI-Hub and WASI-Hub. So you see in the website, you can get more information how important is IoT and the data analysis to address and to measure more on the soil. Second approach, which is more developed also in the paper, is to measure the balance of what is the health of the plant, of the soil, of everything, by measuring the oxido reduction potential, we call the redox potential. And there are several papers, in particular many years of research by CIRAD and by Olivier Husson to identify that if we measure this potential redox and also the pH, we can determine the favorable condition, and we can determine what is a good soil, what is a good plant. And we know that if there is some deviation from the favorable condition, we can have more oxidized soil and more acid or alkaline, and then we can have disease and everything. So I encourage you to look at the papers which are explaining the agroecology approach using the potential redox. So what we intend to do in research is to try to measure this redox. And for that, we use two major innovation breakthroughs. One is a spectrometer approach. That means that we see the miniaturization of spectrometer in some chip, so very small. You see in the right-hand side some miniaturized spectrometer that can give some measure by the light, so in particular in the infrared band. And the other approach is to analyze the data come from the spectrometer and IoT, in particular use artificial intelligence, and this is what we did to analyze information, and is present in this paper. we have developed then what we call the low-cost spectrometer. So we integrate this low-cost spectrometer into a device using infrared spectrometry and working with a mobile application to measure by light. So you see on the right-hand side the concept of the spectrometer. So basically, you send infrared light to the product, and then the light is coming back, is reflected by the echantillon, and there are different absorbance information depending on the atom. So the atom are vibrating at also a different wavelength of the infrared, and then you got a table of answer. You see, for instance, now we did 1,000 measurements for wheat and rapeseed. So, for instance, you see the wheat, and you see, for instance, the different data of 1,000 sample. So you see the absorbance figures depending also on the different wavelength. You see on the left-hand side how difficult it is, because obviously we can measure the redox, but it's a very long and not stable process. So we spent a lot of time to do accurate measurement using techniques which is also described in the different papers. And with the length, the information from the spectrometer and reference information from real measurements, we had a table of data that we start to analyze. So you see on the bottom right-hand side that we have quite a range, a broad range of different value of this redox. So it's quite good. It's not value are all the same. And on the left-hand side, you see that we analyze by different technique. But what was new also and present in this paper, we use a neural network and to do some deep learning. So the major outcomes that we succeed, which is a major breakthrough. So it's unique. So we succeed to measure the redox by light and by optical measurement, by spectrometry. On the right-hand side, you see the redox, which is predicted with an accuracy of 92% by machine learning, by LMP, multi-layer perception. On the left-hand side, you see that by normal technique that we call PCR, PLSR, we didn't get a so good answer. So we had already a model today to succeed to measure the redox using spectrometry and using artificial intelligence, deep learning, multi-layer perception. And on the picture shows that we validate also in the field the different measures to show the redox. What is the business benefits? There's a lot of business benefits of agroecology. So we need to go for agroecology, but all the papers was helping to how to measure agroecology. But if we succeed to measure, we can help to move forward to agroecology. And at the end, we have all the benefit of agroecology. That means we can boost nutrition health, we can integrate different knowledge, we can preserve natural and resource and biodiversity, we can produce more with fewer resource, and also we can enhance resilience of rural people, also that people can also keep working with the land and not going to the city. Also on other practical benefits, we don't have to buy chemicals because all the agroecology is based on no pesticide, no fertilizers, because we recognize that the soil is living, and the soil, a good living soil is enough. Then we have a food which is food resilience, that we can really better control the food production. We also use less water, so that is also very good, and also we increase production. And we can protect, obviously, biodiversity is not destroyed, and we can protect that. And altogether, also, it is a lot of success stories that we have climate change resistance using agroecology. So this is a movement which is not already progressing worldwide, and in Europe is progressing. And also this is a lot of concern, a lot of movement in Africa for agroecology. So this paper presents a good approach that can help to move forward to agroecology. So what are the conclusion and the outlook? conclusion that we can give to farmers a tool to measure agroecology practice. So we call something that exists already in the lab, but very expensive, but now today it's something in the pocket. So we can say the lab in the pocket. So on the left-hand side, you see the products that we can use now to measure only by a click. You can measure the redox potential for the soil, for the plant, for everything. But even we are now developing new measure for new cultures. So we can work in cacao tree, in cacao beans, in manioc, in plenty of different cultures, sugar cane, or depend on the different field. And the second step is also to, based on some initial experience, also working with US Bionutrient Food Association, we can expect even to, from this experience, to develop even a lower cost product with few hundreds, also to try to measure things by light. So we have a lot of idea for moving forward and to helping farmers. So thank you very much for your attention. And we look for cooperation in agroecology for Africa. There is a lot of, let's say, interest for that, and look for projects. And we are preparing some project in Africa. And for that, we need also to get a lot of interest and a lot of contacts. So don't hesitate to contact me. You see my email in the slide. And we hope that we can help agroecology to progress in Africa. Thank you very much.